So today is a rare event. I will perform an experiment. This experiment has two goals. Show what happens if you ingest too much sugar, and illustrate the reducing power of some sugar molecules. So we need an experimental concept. So what I want to do is to mimic the consequence of a person ingesting an excess of glucose. So I will use a certain set of reagents. First, I will take a solution of 1.2% glucose. Okay? When we say 1.2%, it's weight per volume, which means that we added 1.2 grams of glucose in 100 ml of a solution. Then I need to simulate the ingestion of an excess of glucose. So what I will do, I will take my flask and add to it some glucose at a very high concentration. Here we go. Okay. Now I can close my flask again. And the next thing I have to do is to mimic the activity of a person. So what can I do? Maybe I could shake the flask. So I will take the flask and shake it. Shake it hard, and as you can see, it turns blue. So you see what happens when you drink too much glucose or too much sugar. You turn into a Smurf. And that can be embarrassing, especially if Gargamel is around. So how could we explain this change of color? First, we have to define what type of reaction we have. It is in fact an oxidoreduction with a twist. I didn't mention another component in the reaction. So what I did was to add methylene blue to the alkaline solution of glucose. The rest was as I described before.
Wait, I always thought that methylene blue was blue, but your original 1.2% solution of glucose was clear. Why is that?
So before I explain why the solution is clear, let's see what happened when I add methylene blue to another flask of a fresh 1.2% solution of sugar. So here I take this flask, which is labeled S, and I happen to have methylene blue. How surprising. We'll just add here we go. My methylene blue, I will close the flask and shake it. Okay, so it turns blue. Okay, so we let the solution rest for a few minutes. The time I give you some details about the reaction and how we can explain why in the original experiment the solution became colorless after I added methylene blue. As you can see, we have glucose, which is in an alkaline solution. And glucose, under these conditions, can be oxidized into D-glycosylose. This reaction can be accelerated by the addition of methylene blue. And so what will happen is that the oxidation of glucose will be coupled with a reduction of methylene blue. Reduced methylene blue is colorless. But as fast as methylene blue is produced, it will be reoxidized into methylene blue by the oxygen that is dissolved into the solution. So the solution will be blue. But as time goes by, the oxygen dissolved in the solution gets consumed. And when all the oxygen is consumed, we have no reoxidation of methylene blue, and the solution turns clear. Then what I did when I shake the flask, I in fact reintroduced oxygen in the solution, and that led to the reoxidation of methylene blue, and the solution turned blue again. Let's return to our experiment. As you can see, the flask labeled G is colorless again. I can shake it and it will turn blue, because the oxygen that I've introduced in the solution has been consumed in the few minutes I talked. So how could we demonstrate that the bleaching of the methylene blue is due to its reduction? Let's go back to our second flask, the one that was labeled S. It was resting when I was talking about the other reaction, but then it's still blue. It was not bleached. What did happen? Well, remember, I didn't tell you that this flask contained glucose. In fact, it's not glucose, but sucrose. So what's the difference between glucose and sucrose? I shake the solution with glucose in it, it turns blue, but gets bleached again, while there is no bleaching of the solution of sucrose. Remember, glucose is a reducing sugar, while sucrose is a disaccharide containing a glucose and a fructose unit that are attached by a 1,2 glycosidic linkage. And there is no reducing end, so it's a non-reducing disaccharide. So because glucose has a reducing end, it can be oxidized and reduce methylene blue, explaining the bleaching, while sucrose has no reducing end and thus cannot reduce methylene blue, and the solution will remain blue. So this is in fact a control reaction suggesting that a reducing end is needed for the bleaching of methylene blue. A better experiment would be the comparison between maltose, a reducing disaccharide, and trehalose, a non-reducing disaccharide, because both disaccharides are made of 2 glucose units. So in this fun experiment, I show you a colorimetric assay that could be used to measure the amount of glucose in the blood or in urine. Similar assays were used to determine the level of glucose in the blood or urine to monitor glucose level and identify patients with diabetes. Now we have more sophisticated and accurate and fast assay that we can perform. So don't become a Smurf. Take it easy on sugary drinks, whether they are sodas or healthy fruit juice. Take the habit of looking of how many grams of sugar you ingest in one serving of your drink, and you will live better.